Here are some final exam review questions. Start with number 56. The position of an object oscillating on the x-axis is given by x of t equals 2 sine 4t minus cosine 4t. T is time in seconds. I'm going to put some parentheses here that are not required. When we find the derivative of the position with respect to time, that is called the velocity. The position is given. The derivative of the sine of something is the cosine of the same thing times the derivative of what's in the parentheses, so times 4. But there's already a 2 here, so we get an 8. This is called the chain rule. The derivative of sine 4t is cosine 4t times 4. There was already a 2 there. The derivative of cosine of something is negative sine of the same thing times the derivative of the thing in the parentheses. So this 4 is here because of the chain rule again. And this is a plus because the derivative of cosine is negative sine. There was already a negative in the thing we're finding the derivative of. So this expression, 8 cosine 4t plus 4 sine 4t, is the velocity. The question says in the first 5 seconds, how many times is the velocity of the object equal to 0? This says the velocity of the object equal to 0. Graphing calculator required for this question. We're going to graph the left side here. We're going to make all this 8, etc. We're going to make that y1 on the graphing calculator. And we're going to use a window that shows the first 5 seconds. That means from 0 seconds to 5 seconds. So put this in the calculator. Make sure the calculator is in radian mode. Make y1 equal to all this. Use x's where the t's are. Set the window so that 0 is the x minimum and 5 is the x maximum. And you'll get this graph. It's graphed as y equals 8 cosine 4x plus 4 sine 4x, but think of the x's as if they were t's, and think of the y as if it was v for velocity, and that you can see that in the first 5 seconds, that means stop here, the velocity is equal to 0, 1, 2, 3, 4, 5, 6 times. In the first 5 seconds. Anything after 5 seconds is not important. That's number 56. Next one is number 10. Number 10, we are given a graph that looks like this. It's important to see that the graph contains the point to 0, and it's a decreasing function, decreasing, and also appears to be concave up. This entire red thing is decreasing and has a concave up shape, the entire graph, at least the part that's visible. So from what's given, f of 2 is 0, just meaning 2, 0 is one of the points on this function when x is 2, y is 0. The derivative of this function anywhere along the red part is less than 0 because this is a decreasing function. Any decreasing function has a derivative that's 0. I mean less than 0, negative slope, decreasing. Another way to say it is if we were to draw a tangent line at 2, the tangent line would have a negative slope. Also, the second derivative anywhere on this red, in particular at 2, is greater than 0, because anytime any function that is concave up, the second derivative is positive. So the second derivative is positive at 2, but actually anywhere on here, because concave up means all the tangent lines are below the curve. Like this blue one is below the red. Concave up graphs have positive second derivative. Decreasing functions have a negative first derivative. And f of 2 is 0 because the graph contains the point 0, 2, 0. So these three things, there's one of these things is 0, one of them is positive, and one of them is negative. The one that's negative is the smallest. That's less than 0. A negative number is less than 0, which is less than f double prime because that's a positive number. Any negative number will be less than 0, and 0 is less than any positive number. This is why we picked choice C. This is choice C right here. Next one is number 35. It says f of 5 is equal to 3. This is saying that when x is 5, y is 3. F prime of 5 is equal to 2. This is saying the slope of the tangent line to the function f at the point where x is 5 is 2. The derivative is 2. That means the slope of the tangent line at 5. The tangent line at x equals 5 is going to be y minus 3 equals 2, parentheses x minus 5, or y minus 3 equals 2x minus 10. Get 3 to both sides, y equals 2x minus 7. So the whole idea behind tangent lines and functions is whatever the function looks like, the tangent line at 5 and the function itself are close to each other. They're practically the same thing. That's why it says if the tangent line to the graph of f at x equals 5, this is what they're talking about, is used to find an approximation to a 0 of f. A 0 of a function is when the function is 0. A 0 of a function is when the function is equal to 0. But we're going to say the function itself is approximately the same as the tangent line. We're going to approximate when the function is 0 by finding when the tangent line is 0. The theory is the tangent line and the function itself are practically the same thing, at least near x equals 5. So solve this for x by adding 7 to both sides and divide both sides by 2. And that's the answer that's being asked for, number 35. And the next one is number 48. A table of values is given. A question just like this is on the exam that I'm grading here in Kansas City. Exactly like this, of course, with just different numbers. When x is 3.2, f of x is 2.48. When x is 3.3, y is 2.68. When x is 3.4, y is 2.86. And when x is 3.5, y is 3.03. So I'm going to make a very rough sketch of all these points here. Very rough. So there's 1, 2, 3, 4 points I'm going to plot. This is not to scale at all. The question is asking about f prime. This is f of x right here, roughly. F prime evaluated at 3.3. That means the slope, this symbol means the slope of this red tangent line, because that's the point where x is 3.3. So what they want us to do on this question and on the exam that I'm grading today in Kansas City is to say that the slope of that tangent line will be about equal to the slope of the line between this green dot and this green dot. That is the point 3.2, comma 2.48. And this one over here is 3.4, comma 2.86. The slope of the line between those two green dots is the change in y, 2.86 minus 2.48, divided by the change in x, 3.4 minus 3.2. So the derivative at 3.3 which means the slope of this red line is approximately, you can put all of this in your calculator, you'll see that that's approximately 1.9. Well, this green is actually exactly 1.9, but we're saying that number approximates the slope of this red line, even though it's really this slope of a different line. And so since f prime of 3.3 is approximately 1.9, we're going to pick choice D, because (1.9) is between 1.8 and 2.0. Thank you, Ben, for these questions. I'll see you Wednesday.